We're going to continue with the review for test 3, questions 21 through 30. Decide whether the random variable x is discrete or continuous. Again, the definition for discrete, or an overall idea that I can give you to help you distinguish between discrete and continuous, is that discrete variables can be counted, continuous variables cannot. X represents the tension at which a random selected guitar strings have been strung. So the tension, it has to be measured. So is the random variable x discrete or continuous? Since it needs to be measured, it is a continuous random variable. Question 22. A frequency distribution is shown below. Complete parts A and B. The number of televisions in a small town, and use the frequency distribution to construct a probability distribution. So this is similar to the exercises that we did back on chapter 2. We need the sum of all the frequencies, and it will be, since it is a probability, we need a numerator and a denominator. So the probability of having 0 TVs is going to be 23 divided by the overall total. So we need to find out like how many people did they interview in this, or they survey. So clear the calculator. So to find how many people they were interviewed or survey is 23 plus 446 plus, let me check. Dora is kind of sensitive when you work with the virtual calculator. So 446 plus 720 plus 1402. So this is going to be my denominator, 2,591. And each one of these will be divided by the amount. So for the random variable x, 0 is going to be 23 out of 2591. So 23 out of 95, 2591. 2591 will indicate the probability of 0 TVs. And that is, they want 3 decimal places. So 0.00, the 8 is followed by another 8, is 0.009. So 0.009. The next one, the probability of getting a 1. So I know my denominator is 2591. So having 1 TV will be 446 divided by 2591. And that is 0.172. 0.172. The next one is for 2 televisions. It's going to be 720 divided by 2591. And that is 0.278, because that other 7 is followed by another 8, so 0.278. And the third one, 1,402 divided by 2591. That's my total. And that is 0.541. So 0.541. And we check. So it has another part, 2 more parts. So the best way to answer this question without actually graphing it, you look for the highest should be 3, then next the 2, then the 1 and 0. So you look at the highest being 3 households, which will be this one, then the 3, then the 2, the 1, and then when it is 0. So this one follows that pattern. That's why we're going to answer C. This one is reverse, and you can expand it if you want to see, but notice 3 should be the highest, and the 2, the 3. So this one is in reverse, the same as this one. So the answer that looks more like the table distribution is, the graph will be C. Next is asking for, describe the histogram shape. So this form of histogram is the bars are touching, And this one, the tail, it is towards the left, so it is a skew left. It's based on the tail. Remember, the level of skewedness is based on the tail. And that's it for question 22. Question number 23. It is similar. So they're giving us a probability. Find the probability of randomly selecting a household that has 1 or 2 televisions. So they already found the probability here. So it is similar in a sense that in this particular one, what makes this one different is that they're giving you a table of values where the probability is given to you on this one. In the previous one, we had to calculate the probability because they gave you the frequencies for each one of the variables. So here, find the probability of randomly selecting a household that has 1 or 2 televisions. So it says they have 1 or 2. So all we have to do is add these 2 probabilities because they already found the probabilities for you, and or means addition. So we are adding 0.03 to 0.26, and these are mutually exclusive. There is no overlap, so that I don't have to subtract anything. This one is 0.29. Let's see what happened. What did I do? What did I enter in my calculator? 0.03 and 2 is 0.26. Find the probability of randomly selecting a household that has 1 or 2. Oh, I added 0 televisions. Make sure that you look at it the way it is. 1 or 2, not 0 or 2. So 1 or 2 is 0.14. If you use the right numbers, you'll get the right answer. 0.14 added to 0.26, and that should give us 0.40. That's why I said that it was wrong. So 0.40 or 0.4 will work. So next, find the probability of randomly selecting a household that has 2 or more televisions. 2 or more, that means 2 or 3, because we don't have any more than 3 in the table. So this is going to be 0.26 added to 0.57. Those are the 2 probabilities in decimal form. So this one is 0.83. Next, find the probability of randomly selecting a household that has between 1 and 3 televisions, inclusive. So that means that they have the 1, the 2, and the 3. So 1, 2, or 3 are the probabilities that we will need to add in order to get this answer. So the 0.14, 0.26, 0.57. So 0.14, 14 plus 0.26 plus 0.57, and that is 0.97. So we have one more part in this question 23. So question 23, find the probability of randomly selecting a household that has at most 2 televisions. So it says at most 2 televisions. That means they don't have any more than 2. They either have 2, 1, or no televisions. So at most 2 again means 2, 1, or 0. So that means we're going to add these 3 numbers, the first 3 probabilities, in order to answer this question. So this is going to be 0.03 added to 0.14 added to 0.26, and that gave us 0.43. So next, determine the required value of the missing probability to make the distribution a discrete probability distribution. So the probability of 4, since we have the probability of all the others, so in order to be a probability distribution, each one of the probabilities must be between 0 and 1 inclusive, and the sum of the probabilities must add up to 1. So we have all the probabilities. We're only missing the probability of variable x. So in order to find the probability, all we have to do is add. There's more than one way of doing this. I can add the given probabilities, and then I will be subtracting the sum that I am getting from 1, because once I have the probability of 4, they have to add up to 1. So 0.73, so I will do 1 minus the 0.73, and that will give you the probability of 4, in this case 0.27. Question 25. Determine whether the distribution is a discrete probability distribution. By looking at them, each one of the probabilities are positive. They are between 0 and 1, so it does pass that test. But then what we need to check it is if the sum of the probabilities adds up to 1. So 0.09 plus 0.21 plus 0.40 plus 0.21 plus 0.09. So 0.09 twice, 0.21, 0.40, 0.21 again. So we add that, and it does add up to 1. So since it satisfies the two conditions, each one of the probabilities are between 0 and 1, that means none of them are negative. And the other condition is that the sum of the probability must add up to 1. So it satisfies both. So the answer to the question, is the distribution a discrete probability distribution? It is yes. And the reason is because the probabilities sum to 1 and are all between 0 and 1 inclusive. So you have to make sure that you also agree with the explanation. So next question. Determine whether the distribution is a probability distribution. So we look at the fractions, the probabilities. It seems that they're all between 0 and 1. And none of them are negative. So what we are to check it is if the sum of the probability adds up to 1. So we'll add in 3 divided by 5. I'm going to not use parentheses because they're all fractions. So let's see how that goes. 1 divided by 2 plus 1 divided by 10 plus 1 divided by 25 plus 1 divided by 50 plus 1 divided by 4. So I'm getting more than 1 on this one. So it does satisfy that each one of the probabilities are between 0 and 1. None of them are negative. But the sum of the probability adds up to more than 1. So it's going to be no, because the total probability is not equal to 1. So next, complete parts A and B. Find the mean, variance, and standard deviation of the probability distribution. So in this question, you will need to use the graphing calculator, and we'll go to Stat. You'll enter the 2 columns in the calculator. The variable x is going to be the list 1, and list 2 is going to be the different probabilities that you're given. So it just happened that my list 1 matches the dogs 0 to 5, very good. And then I just have to, I can type over or I can just clear. I prefer to clear the column. So I move the cursor to the top and press clear and then enter. And make sure that it does matches. You cannot just enter it in any order. It has to match the pair that you see on paper. So in here is going to be 0.682. Press enter. 0.197. Enter. 0.082. 0.020, 0.013, and 0.007. Okay, so then we're going to go back to stat. You're performing calculations. 1 bar, press enter, and I have to tell the calculator that I want to take the data from list 1. The comma is above the 7 in this calculator, and then second list 2. And then you press enter. So my mean is going to be the X bar. It will be equivalent, it's an approximation. The sample mean will be an approximation of the population mean, that is the mu. So this is 0.507. Or they say they want you to round it to 1 decimal place. So this is going to be just 0.5 because the 5 is followed by a 0. So 0.5. And then we need to find the variance. The calculator doesn't give you the variance, but it does give you the standard deviation. So what I recommend is that you take like 5. I usually take about 5 digits of my standard deviation, 0.9069, because just it will increase in inaccuracy if you use only the first digit. So 0.91069, and then you're going to square that value, and that's what you would round to 1 decimal point. So in this case, it will be 0.8. Okay, so next, question 20. Oh, it has another part. Find the standard deviation. And we do have the standard deviation, the 1 decimal point. So the standard deviation was 0.91069. So 0.9 in this case, because the 9 is followed by a 1. I forgot that I saw another part. Okay. Then it says interpret the results in the context of the real life situation. A household on average. So the average was 0.5. So that means that it's either A or C. 0.5 dog with a standard deviation is this part here, 0.9 dogs. So it will be part C. It doesn't say 14 dogs. Okay, next question, 28. What is the total area under the normal curve? The total area under the normal curve is the sum of all the probabilities, is the same concept, is 1. Next, find the area of the shaded region. The graph depicts the standard normal distribution with the mean 0 and a standard deviation of 1. So notice in here it gives you the z-score is 0.63. That indicates the area under the curve. In these videos, I'm going to demonstrate using the shortcut with a calculator. So if you look at this handout that I highly recommend that you have with you, if you're interested in using the calculator, it looks like this graph right here that has the area to the left. So if you scroll down, it tells you the steps to follow. It's going to be second vars. Then you're going to use, go over and choose number 2. And this is how you need to enter this in the calculator. The input is what we usually mess up. So I recommend to check with the calculator, but you're better off if you don't feel comfortable or if you don't have these type of calculators, then you should do it by hand. So in here, we're going to go, let me look at the question again. And the z-score is z of 0.63. And again, the areas are given to you are always the areas to the left. In this table of values is the area to the left. So if I were to find this, I'll show you by hand on this one, 0.63. So if I look at my table of values, z of 0.63, there is a negative table and there is a positive table. So if we need to choose a positive table because it says z of 0.63. So you go to 0.6 and you move over to 3. And in this case, we should get 0.7357. That is the probability under the curve for the values of z equal to 0.63. So 0.7367, I'm sorry, 7357 is the answer. Okay, that's the z of 0.63. Again, 0.6 and then 0, 1, 2, 3, 0.7357. So using the calculator, let's get the calculator. So in the calculator, it says you go press the second key and then vars, and that takes you to this menu. Choose option 2, so you scroll down to 2 or press 2. Then you press enter, and then you're going to enter the negative that is in parentheses, the negative 100, followed by the comma above the 7, and the z value in this case is 0.63. And then you close the parentheses, press enter, and notice that it contains a lot more decimal places because the calculator is programmed with a lot more decimal places than the 4 that you are given in the table of values. So therefore, this is 0.7357, which is what we got from the table of values. So again, if you have this calculator, it's wonderful. If you don't, then you just use the table of values, the table that I gave you, 0.7357, and they usually want 4 decimal places. Okay, next question, number 30. Find the area of the shaded region under the standard normal curve. So here it is the area to the right. And again, the table gives you only the area to the left. So if we look at the handout, then it is the area to the left. So this one it was area to the left. This one is to use with the area to the right. So it doesn't matter how much to the right it is. It's just shaded to the right. So the steps are similar, but notice in here, you're going to enter the z-score first, then comma, and then the 100. So in this question that we have, it says the z of 1.57. So 1.57, I'll get my calculator. And the first process is exactly as what we did before. It is second vars, then you go to option 2, press enter, and now we're entering 1.57, comma, 100. So the input changes, and that's what you need to be aware of. The calculator will take care of the subtraction part of it. So this one is 0.0582, and you just round it because it says 4 decimal places. So that's the value that we are going to enter in the input box. If you were doing this by hand, you will have to subtract and all that, but here the calculator will take care of that for you. There is no need to subtract anything. What you get from the calculator is the answer that you will input, 0.0582. Okay, next. I'm going to continue with this ones. They're so much fun. So I'll extend the amount of questions that I put in the label. So question 31 is the area between. So when you look at the handout, it is not going to be the area to the left or the area to the right. You scroll down because it is the area between. So the steps are different. So still the beginning, second vars, option 2. The input here, you're going to enter the z-score, the smallest, and then it's usually the z-score from left to right, the smallest to highest. So separated by a comma. So we go back and look at the question. So this one is going to be, I'm going to enter negative 0.8, comma, 1.5. So in my calculator, press clear, and then I go second vars, option 2, press enter, and it will be negative 0.8, comma, 1.5. Negative 1.8, 1.5, according to what you see there, they want 4 decimal places, so it's 0.7213, 0.7213. Okay. And so those are the basic three 3 cases that you can expect to find, area to the left, area to the right, and the area between. So I'm going to stop the video here, and then we'll continue in our next video.